Alright, to finish this unit off, let's look at some diploma questions you could get asked. So numeric response for the function f of x is equal to negative 2 square root of x plus 4 plus 3. The x-intercept is equal to negative k. The value of k to the nearest hundredth is. Okay, so we need to find out when our height is 0. So when is f of x equal to 0? So we're going to substitute in 0 and then start solving. Now this is numeric response. You could use a calculator, but we'll do it algebraically. So we're going to subtract negative 3. We're going to subtract 3 from both sides and get negative 3. And then we're going to divide both sides by negative 2. And finally, we're going to square both sides. So you get 9 over 4 is equal to x plus 4. We'll subtract 4 from both sides. Now you're going to have to do a bit of equation work here, but you're going to get negative 7 over 4 equals x. Now we go and look at how they want us. Nearest hundredth, so that's negative 1.75 is what x, or in this case, this is actually k. Let's take another look at a diploma question. So the graph of the function y equals f of x is shown below. Sketch the graph of y equals square root of f of x and state the domain and range. So when I'm going to take the root of this graph, I'm going to look for some key points. I know the x-intercepts are key because those are invariant points. Same for at the height of 1. Those are invariant. So right away I can plot those when I'm taking the square root of something. I also know that I can't square root a negative, so I can't do anything with that at all. I'm just scratching out this for you. I probably would not scratch this out if it was a diploma question. And some things to note is the left-hand side seems to keep on increasing, and our right side of the graph appears to be just have no slope. So we're going to take this highest point, we're going to square root 2, which is about 1.4. And it's really important that when I go to actually sketch this, it also has just no slope. On the left side, though, it's a little bit different. When I go to square root 2 at 1.4, this should be increasing. There we go. We've sketched that graph. So let's take the domain then. So for our left side of our graph, x such that x must be less than or equal to negative 3. And then on the right side, x must be greater than or equal to 0. And x is a real number. Now for our range, for our lowest point, it's definitely 0. So y such that y is greater than or equal to 0. The left side does keep on increasing to positive infinity. The right side doesn't, but it only matters that one part of it hits a high infinity. It doesn't matter if the other side has no slope and keeps on going. So therefore, y is just part of the real number system, and we're done. Let's take a look at another diploma question. So the graph of y equals f of x is shown below. When comparing the graph of y equals f of x with the graph of the transformation y equals square root f of x, the x-intercepts are and the y-intercept is. So the statement above is completed by the following information. So either they're the same or they're different. Now without doing too much work, I know that these x-intercepts are equal to a height of 0. Well, when I take the square root of 0, that's still 0. So they're invariant. So they must be the same. Now that only leaves me with the y-intercept then. Well, this is the vertex. When I take the square root of a height, it's going to be different. So unless it was a height of 1, it might be the same, but it's definitely not. It looks like it's at 7, 8. So our root is going to be somewhere down here. So it is definitely different. So our answer is C. All right, one last question for the unit. So the graphs of the functions y equals f of x, y equals g of x, and y equals h of x are shown below. Each function is transformed into y equals square root of f of x, y equals square root of g of x, and y equals h of x. Ooh, mouthful, respectively. So the number of invariant points on the original graph and its transformed graph for diagram 1 is diagram 2 and diagram 3. So we need to go through and see how many invariant points we'd have. They've all been square rooted. So invariant points happen when the height is 1. So when y is equal to 1 and y is equal to 0. So if I go and look at our graph 1, we have y is 0 here, y is 0 here. Those are our x-intercepts. And then we also have a point where the height is 1 in this parabola, and the height is 1 here as well. So therefore, there is 4 invariant points. For our second diagram, We have no x-intercepts. This is a minimum. The parabola is going up, so it's never going to have an x-intercept. We do have, it appears, the vertex is right at 1, exactly at 1. And so therefore there is only one invariant point. Finally, diagram 3. Again, our a value is positive, so it's going up, and our vertex is already above the x-axis, so there will never be an x-intercept. Also, our vertex starts at way higher than our invariant point, a height of 1. So therefore, there is none.